Hello everyone, I am Dilip and this is the programming project that I've worked on. The topic that I've used here is finding the closest pair of points in a two-dimensional plane. In this problem, we are finding the distance between 2 points using the Euclidean distance formula. That is, the distance between points Pi and Pj is under root of Px minus Qx whole square plus Py minus Qy whole square, where Px comma Py symbolizes the point Pi and the coordinates Qx comma Qy symbolizes the point Pj. And the closest pair of point algorithm represents a fundamental computational geometry approach that finds the practical uses during the real-time operations, especially in situations that require measurements of proximity. There are a number of uses of this algorithm, the closest pair of points, and the one noted here are few among them. Like it's useful in the data mining and machine learning, and for geographical locations and many more. Now we are talking about the problem statement over here. Like as I've already discussed, like we are given a two-dimensional plane and there are a set of points that are given in the 2D plane. Our main thing about finding is like we have to find the distance between the 2 points over here, like the closest points which has the lowest distance between them. And to find this thing, we are using two approaches over here. One is the brute force approach, and another one is the divide and conquer approach. And as we already know, like in a brute force approach, we try to find all the possible scenarios in the problem. So here we are considering a single point, and then we are finding the distance with each every other point that is present in the two-dimensional plane using the Euclidean distance formula. And then we are for considering the smallest value, the smallest distance that is found between the 2 points, and that is a solution. So that's what we are doing. We are considering the distance between 2 points as infinity, and every time we are getting a distance which is comparatively shorter than this minimum value, we are replacing it with a minimum value. So finally, by the end of the all iterations, we will be having the shortest distance between the 2 points. So this algorithms works very well when there are a small set of small set of points that are available. And the runtime for this algorithm is order of n square, as we're using two loops for that. So like considering with each point with other point, so it's order of n square. And the other approach that we are going to use here is the divide and conquer approach. In divide and conquer approach, we are basically dividing the problem into two sub-problems. And furthermore, we are dividing the problems into the other sub-problems and all. And finally, like when we reach the base case, like we'll be trying to find the solution for the base case, and recursively, our main problem will be getting solved here. So I'll now discuss the approach that we are doing in the divide and conquer. In this problem, we are basically sorting the points based on x-axis and dividing the set of points to the left plane and the right plane. Now here in the left plane, we'll try to find the shortest distance over here, and let's call it as a delta. Similarly, we are finding the shortest distance over in the right side of the plane, and we'll call it delta 2. And we are also considering a strip where few points, the few points which are left to the strip, which are present, which comes under the strip and left to the plane, and few points which are coming right to the plane, and we'll try to find the distance between those points as well. And now we are considering the shortest distance between delta 2, and the values that we got in the strip, so that we will get a final solution and which will be optimal. So that's what we are doing over here. And the divide and conquer approach is like dividing the main problem into sub problems, and like by solving the base problem of the sub problem, we recursively solve the complete solution. And the runtime analysis that we are going to get here is order of n log n, which is comparatively low when compared with order of n square. So this is the code that I have worked on for this algorithm. Uh, I mean, this is the screenshot of the code, and this is the output that has been generated by this algorithm. Now, let's discuss about this algorithm. I mean, discuss about my program. So I'm considering 10 iterations over here. My start point will be 10,000. So first time it's gonna consider 10,000 randomly generated points and try to find the distance, closest set of distance between them. And I'm gonna end at 1 lakh, and my step will be around 10,000 here. And here you can see the code generate the random points, like where I'm using mat.random function to generate the random points here. And when you see in line number 104, trying to find I am trying to find the time taken, I mean the average time taken to find the closest pair of points for 10,000 uh points value. So here I'm starting my time, and I'll be running the brute force code for that, and then I'll complete the time. So this sum of algorithm one will be the difference between these two times T2 and T1. So where I'll be able to get the correct time, like how much time is taken to find the set of points. Now, if you see my brute force algorithm over here, here I'm using two loops, and I'm trying to find the distance between 2 points. I mean, all the possible scenarios over there. And if the distance is less than the minimum distance, I'm just replacing the minimum distance with the distance, so that I'll finally be able to find the shortest distance over here. Similarly, this is my divide and conquer approach, where this is the base case scenario. Like if the length of the points is less than 3, then I'm directly gonna find by using the brute force approach itself. If it's not the case, I'm dividing the complete length into two parts and considering the finding the shortest value on the left plane and finding the other shortest path in the right plane and strip, and finally finding the smallest value over here. So this is the code what I have written, and this is the output that has been generated. Like when I'm running this algorithm, it's giving me the average brute force time for each iteration, starting from 10,000 to 1 lakh. This is the code that I used to generate the graphs over here, like which I'll be discussing next. So these are the brute force algorithm results that I got, like for the in iterations starting from 10,000 to 1 lakh. This is the theoretical running time that has been taken for the algorithm to run. And empirical running time is based on the output that we got. Here, I'm finding the ratio by dividing the empirical running time with the theoretical running time, finding the maximum value over here and multiplying with the theoretical running time to get the predicted running time. Now we are going to generate this graph by taking the results of the empirical running time and predicted running time on x-axis and y-axis, like where n is the input in the x-axis and the runtime millisecond will be in the y-axis. So you can see the red dotted line over here is the predicted running time for the brute force algorithm, and the blue line over here is the empirical running time for the brute force algorithm. Similarly, in divide and conquer, you're going to take some values and you're finding the theoretical running time, the empirical running time.